Okay, today we're doing the 8.6 Properties of Logarithms video. Okay, first we're going to be doing some of the basic exponential things we learned in the first half of this chapter in order to understand the properties of logarithms that we're doing today. So remember when I had the base times the height. If the base times the height, base is the same. Both bases are 2. This means I can add the exponents. So I end up with 2 to the x plus y. When it's division and the bases are the same, basically you're subtracting the exponents. If you raise a base to a power and then all of that to a power, then it becomes the base times the 2 powers are multiplied together. So it's 10 to the x times y. All right. Now, last class we were learning about log. Remember that what this is saying, log base b of b, remember that this is saying, let me give you a highlight. It's going to make it more plain. Base b to the what, we don't know, is equal, right? Because this is equal to x. So that's badly drawn. Equals x. That's better. Okay. So it's b to the x equals what is inside, which is b. Okay, so what in this case is x? Well, remember that b is really b to the 1. So x is 1. Same with this second one, this next equation. Okay, log base b becomes b to whatever is outside equals what is inside. So in this case, x is 20. This is demonstrating the inverse property of logarithms and exponents. Okay, so the property of equality for logarithms, and remember that our base cannot equal 1, and that our value has to be positive. What's inside has to be positive. Okay, log base b of x is equal to log base b of y if and only if x is equal to y. If you think about it, it's logical. If I say x squared equals 5 squared, you know that x is 5, right? Let me write that down so you can see it. If I say that x squared equals 5 squared, you know that x is 5. If I say that 2 to the x is equal to 2 to the 5, again, you know that x is 5. Same idea. If I say log base b of x is equal to log base b of y, you know x has to equal y. All right, now, given that's true, and given all the properties of exponents we know, remember we learned that if I multiply the 2 bases, I add the exponents. Well, now we kind of are undoing it because we're actually dealing with exponents. If I multiply the exponents, I can split it apart into an addition. All right, quotient. If I divided the same base, I merely subtracted the exponents. Well, now if it's divided, I subtract. Okay, and remember that if I had a base to a power, then I multiplied my powers. Now I'm saying if I take m to the p, if I put a power inside my log, I can actually bring this power down front, and it's now p log base b of n. All of these work, and these stem directly from the properties of exponents. Okay, example 1. Write each expression as a single logarithm. This is called compressing or combining your different logarithms. Okay, so first step, since this is a minus, I can turn the two interior bits into a division. Now, once I do that division, what is 32 divided by 8? 32 divided by 8 is 4. Well, this is log base 2 of 2 squared. We already saw that if these match, all of this just becomes 2. So my answer to this one is 2. Okay, now here, what I'm going to do is first I'm taking this 3, I'm bringing it up here as an exponent. See, that's what we did right there. And then plus log base b of y. We haven't changed anything. But now, because it's a plus, and they both are log b, I can combine them into a multiplication inside. So now I have condensed this into log base b x cubed y. All right, example 2. Expand this. First off, we know that this whole square root, cube root thing is an exponent of 1/3. This is what we learned the first half of this chapter. All right, so I can rewrite it with an exponent. The reason I want to do that is I can now bring it down over here and see, 1/3 is now out here. I no longer have an exponent. Now I have a division. Once I see it's divided, I can change that into subtraction. Log base 3 of d squared minus log base 3 of c multiplied by 1/3. Okay, now I still have this exponent up here. So I can bring it down front, and there it is. So I have 1/3 2 log base 3 of d minus log base 3 of c. These are expanding. All right, now, example 3. If log of 5, this is base 10 because it's a common logarithm. If log of 5 is 0.699 and the log of 7 is 0.845, find a decimal approximation for each logarithm. Okay, and what we have to do is look at 175 and say, okay, I need this to be factors of 5 and 7. So, first off, I noticed that 175 is 25 times 7. Well, there's my 7. But 25 is 5 squared, so that's my 5. So now I have it in 5s and 7s. All right, I can split it apart because of that multiplication. Okay, here's another error. Good grief. This is supposed to be a plus. Since they're multiplied inside, I can add them together. Log of 5 squared plus log of 7. I can split it apart because of this multiplication. Gives me an addition. All right, now I have log of 5 squared, but I can take this 2 down to the front, and there it is. So now I have 2 log 5 plus log 7. Well, I know what log 5 and log 7 are, so I can plug those values in. Okay, remember I had 0.699 for log 5 and 0.845 for log 7. Remember, this is still being multiplied by 2. Put this into my calculator, out pops that ever so lovely answer, 2.243. And I'm done. Okay, now we still have log 5 and log 7, but now we're given log 2. How do we get 5 and a 7 out of 2? 5 or a 7, and or. Okay, well, 2 is actually 10 over 5, right? Okay, so I can change this into log 10 over 5. Well, that division becomes a subtraction. So now I have log 10 minus log 5. Well, I know that log 10 is 1, right? This is log base 10 of 10. So 10 to the what is equal to 10? Well, 10 is 10 to the 1, so 10 to the x equal 10 to the 1 means x is 1. So this is 1. All right, so we take all of log 10 and that becomes 1. We know log 5, so we plug that in. 1 minus 0.699 gives us a fabulous answer of 0.301. Okay, example 4. Now we've got to solve this. All right, I look at this and I think, okay, well, first off, notice that I have log base b and log base b, which means I can take the interior bits and set them equal, right? If they're both, we're taking log base b of both of them, then they have to be equal. So I take the x plus 3 squared, and it becomes x plus 3 squared equals the 36. All right, now I square root both sides, and I get x plus 3 plus or minus 6. All right, now I've got to move the 3, so I subtract 3. Okay, so here's my negative 3 plus and minus 6. So negative 3 plus 6 is 3. Negative 3 minus 6 gives me the negative 9. So I've got to check these two answers. So first I'm going to check 3. I plug 3 into the, let's see, what color am I going to use? Yellow. I'm going to plug 3 into this part of the problem. See if it can equal that side. Well, if I plug in 3, I get 3 plus 3, which is 6. I bring the 2 up, and I have 6 squared. So I have log base b of 36. Check. It worked. All right, now I'm going to check. I'm going to see it doesn't end up working. Negative 9. If I plug in negative 9, I get negative 6. I cannot have a negative inside of a logarithm. That negative 6 doesn't work. So this is a non-solution or an extraneous solution. So my only solution is 3. So that's my answer. All right, and we're done. And here's your homework assignment. All right, have fun.